Hello guys, welcome to my channel. This is Ehsan, and in today's video we're going to take a look at another interesting thing in LTSpice, how to simulate a Monte Carlo simulations. Okay, first suppose that we have a regulator, linear regulator like LT3088 that I already discussed in electronic designer playlist. I provide you some questions and then I answer those questions for you to become a great electronic designer, to have a great mindset. So the output supposed to be a fixed voltage after some time. Okay, for example, in this case the output would be almost 1.5 volt. Let me just simulate this and see the result in here. So this is the output voltage. You see, after some time you can see the fixed voltage of 1 point hit C, and you can see the result in here, 1.5 volt fixed voltage in the output. But in the practical scenarios, you can see that there is some errors for these devices, such as resistors or capacitors in regulator, or maybe even in the IC, for example, W over L of the transistor, or the threshold voltage of the transistor could be variable, and even the supply voltage could be varies, and this is going to make some difference in the output. In order to simulate this in LTSpice, you can use Monte Carlo simulations, and if you go through the help of the LTSpice, you can see and type down just MC. You can see in this table with the real straightforward explanation that MCXY, with that you can see, and this is the explanation, a random number between x times 1 plus y and x times 1 minus y, and y would be your tolerance of that, for example, resistor or capacitor, with uniform distribution. Okay, with uniform distribution, the distribution is just uniform, and you can see that. What does that mean? So in order to do the Monte Carlo simulation, I already provided this simulation, and this we're gonna have some make some changes. Okay, for these four values for resistors and capacitors, as you can see, I defined the values something like this. You had to use this accolade, open accolade and black and close accolade, to introduce a new variable. Okay, and in that I used the keyword MC, and this is X and this is Y, and I placed the values in here for different elements, and this toll underline CL, toll underline R1, these are just related to this errors of these resistors and capacitors. For example, 0.01, which means 1% error for this resistor, and so on and so forth. And another thing to do that, this is a simulation that requires lots of runs. This is not in just one run, because you had to see this changing in these numbers in a random way, random numbers, with respect to the tools that you define as a tolerance, with uniform distribution in different runs. This is not in just one case, this is in different runs. So I had to define dot step param run from 1 to 20, for example, with a step of 1, which means 20 runs for these simulations. Or you can change this number 20 into whatever you want. For example, if I write 10, which means 10 runs. Okay, now I'm going to run the simulation, and I expected the output to be vary from 1.1 volt in 10 different values at the output. Okay, now I'm going to run the simulation and see the result, and ta-da, this is, you can see it in here. This is the different values for the output. You see this is 1.5 volt, and these are just different values for the outputs with the uniform distribution. In Monte Carlo simulations, it is better to have a Gaussian distribution rather than the uniform distribution, because in the real world actually the main change happens in the mean value or in the nominal values of that element. So we're going to take a look at how we can define a Gaussian distribution on the next video. But for now, this is just some setting, some simple setting for these linear regulators, for these 4 different elements in order to run the Monte Carlo simulations. Just to recap this video, you had to define the variables into open and closed alkaloids, use MC keywords, define your tolerance, and don't forget to use .step to show how many runs you want in your Monte Carlo simulations. For example, if I change it to I don't know, 20, you can see 20 results in the output, you see, and the distribution is just uniform by the default. Okay, that's it for today's video. I hope you like it. If that's the case, please give me a thumbs up and share this video with your friend. I will see you in the next video. Thanks for watching.